Welcome to JD's Prep. In this problem, we are given the equation x squared plus 4x equals 2, and we want to solve this equation by completing the square. The method of completing the square involves adding a number to both sides of the equation in order to make the left side, the one with the variables, a perfect square. Once we make it a perfect square, we can then use the square root property to solve the equation. In order to make that left side a perfect square, however, there is a very particular quantity that we have to add to both sides. And if we think of this left side as x squared plus bx, then the quantity that we have to add to both sides is half of b squared. If we add that to both sides, then that's going to make the left side a perfect square automatically. And by adding it to both sides, we're not changing the solutions of the equation. In our case, with the equation x squared plus 4x equals 2, our b is 4, so b over 2 squared is going to be 4 over 2 squared, which is 2 squared, which is 4. So that means in order to complete the square, I want to add 4 to both sides of this equation. So we'll have x squared plus 4x plus 4 equals 2 plus 4. All right, this new amount that we're adding to both sides. But now on the left side, this whole thing here, the x squared plus 4x plus 4, this is the perfect square, x plus 2 squared. So we can rewrite that as x plus 2 squared. And on the right side, 2 plus 4 gives us 6. Now I have my equation in the form where one side is a perfect square on the left, and the other side is a positive number. This is the perfect form for us to use the square root property and take the square root of both sides of the equation. The reason is that with the square and the square root, they are effectively canceling each other out, leaving me with just the x plus 2, as long as I always remember that when I take the square root of both sides of an equation, the other side I must include the plus or minus. And the reason for that is that when I square the x plus 2, it's always going to end up being the positive 6. If I have x plus 2 being positive and I square it, it'll be positive. But if x plus 2 was negative and I squared it, it would still end up being the positive 6. Since I do not know whether the x plus 2 was positive or negative, I must include this plus or minus here every time I take the square root of both sides of the equation. Now that I've done that, I've gotten my x over here out of the parentheses, which makes it much easier for me to solve for x. All I have to do to accomplish that is subtract 2 from both sides of the equation, and that will give me x equals negative 2 plus or minus the square root of 6. Where we typically write them in this order with the plus or minus in the middle. So these two solutions that we have here now are x equals negative 2 plus the square root of 6, and x equals negative 2 minus the square root of 6. Either one of those two x values, if we plug them back into the original equation, would give us a true statement.